Hi, and welcome to the screencast. My name is Andy, and today I'm going to talk about REST. Therefore, I'll try to give a short explanation of what REST is and what the ideas behind REST are. And also, we are going to implement our own small REST example along with a simple web page and a RESTful web service. So, what does REST stand for and what does it do? Well, REST stands for Representational State Transfer and is one of the core ideas of the World Wide Web and the HTTP protocol. And the idea is that everything the server needs to know is contained within the request. So everything we want the server to know and do will be contained in the request URL. And I have an example here. The first URL doesn't follow the REST principle. It's a simple URL, mydomain.com, without any further information. There's simply a query string which provides a customer number and an action to perform. And the problem with this URL is that except for the web application, no other entity knows what to do with it. So if we have an intermediate cache or proxy server, it does not know that this URI might actually create a new customer. So it might cache that away, or it might re-trigger the whole URL and might create a second customer. Now, if we have a look at a second URL, we can see that it's not a normal GET request, which is normally issued by the browser, but it's a PUT request. And the URL is mydomain.com, and in the URI string is customer / the customer number. So we have an exact address of the customer which we're talking about, and by using the HTTP word PUT, not only our application but also all intermediate caches and proxies know that we're going to create something on the server. Now, what are those HTTP words? Well, there are 4 of them. One is the PUT, which sends or creates something new on the server. The other is GET, which is what is usually created by every browser, and it just retrieves information from the server. And the idea is that a GET request never changes the server state. If you want to change the server state, like check out a basket in a web shop or anything the like, we have to issue a POST request. And this can send information to the server to update the state, and this is the only method which is allowed to do so. And finally, we have the delete statement, which simply requests the server to delete the addressed resource. So, what are the benefits of using REST? Well, the most obvious one is caching. A normal cache or proxy server will omit the query string and will only cache the base address. Therefore, if we have any information in the query string, to render the information correctly, this request cannot be cached. Also, we can increase our scalability, as the server always knows what we're talking about and what we want him to do, so we can distribute our application across multiple servers, and each server will know what we're doing if we issue a RESTful request. And also there are benefits in the SEO area, because if we have a look at our example below, the first thing is a RESTful URL for an article in our example shop, and this will be indexed by a search bot like Google. But if you look at the second URL, the Google bot will probably skip this because it does not like caching query strings, because there might be confidential information in it. So our second URL will not be in the Google index and cannot be searched. Now, what are RESTful services? Well, the idea again is pretty simple. It's just using the REST principle on web services. So instead of sending a whole bunch of XML, which I show in the lower part of this slide, we simply send a request with an URI describing what we're talking about. In this case, it's a counter service, so we want to increment a counter by 10. Therefore, we call a sample domain /counter / the name of the counter, and we supply the increment. And we can see if we would implement this as a SOAP service, we would have to send a whole bunch of XML to the server to achieve the same. Now that we know the theory, let's look at a practical example. And as already shown, the example we are going to build will be a counter service. So if we call counter/name with the put verb, we will create this counter. If we call get/counter/ and the name of the counter, we will return the current state without modifying it. If we call post/counter/ and the name of it, we will increment it by 1 and return the current value of the now incremented counter. And finally, if we call delete/counter/ the name of it, we will again delete this counter. Now let's directly dive into the code. I will be using the SIRIUS tutorial example, which I've used to create in the previous screencast. So I'll link that in and you can clone it from GitHub, and everything else will be now created live so you can follow me directly. And the first thing we want to do is we are going to create a controller class which responds to web applications. And of course, we are using the SIRIUS framework, which we've created to build powerful and scalable web applications. You can also clone it from GitHub and use it in your own projects. It's covered under the MIT license. So we've created a counter controller. Let's implement the correct interface. And let's register it so that it's discovered by the dependency injector. We always need to provide an onError method which takes care of errors. In our case, we just pass it on to the web browser. So we send an internal error state and the error which was submitted. Now let's create the method which takes care of our counter services. Now a method handling web requests always needs to have a web context as first parameter, which will contain the request. And in our case, we want to know the name of our counter, which we saw in our example URLs. So we have a second parameter called name. And let's tell the web server what URLs we're interested in. So with the rooted annotation, the web server will know that we are interested in /counter/ and a name, and this will be filled in the first parameter, which is our parameter name. Now the first thing we want to do is we want to handle the put request. So we create a new counter and put it into our counter map. So we will keep all our known counters in this map in memory, which will just be good for our example purposes. Now that we've created and initialized our counter, let's return the current state of it. We therefore call respond with, and we create a direct response without any formatting. We return OK as result and the value of our counter. If we're not called via the put method or put verb, we will report an error. So if we receive anything but a put request, we will respond with method not allowed. So let's compile this. And let's start the server. Alright, our server is up and running. Let's call our service. We will use the curl utility to create all kinds of HTTP requests because it's quite easy to use, and we will be able to submit any request we like. So we create a put request now for the counter with the name test. And as we can see, it just returned 0 as the counter was initialized with 0. So let's go ahead and implement the get and post methods. Alright, if we receive a get request, we check our counters map for the counter with the given name. If we cannot find it, we will return a not found status. If we found it, we will return the contents of the counter. In order to handle the post method, we more or less do the same, except we also want to increment it by 1. So let's do this quick and dirty and just copy it and use the increment and get here. Alright, if we recompile our code, we now can use the get method to read the counter without modifying it. And it still returns 0, and we can call that again and it returns 0. Now if we change that to a post request, we can see the counter incrementing. And if we switch back to our get request, we can see that the counter remains again the same. Now if we try to call the delete method for our test URL, we receive quite a long error message, which basically says that our delete is not implemented yet and the method we call is not allowed. And also, if we use a get method but for a not yet created counter, we receive an error, and in this case it's a not found state, which tells us that the counter does not exist yet. So let's go ahead and implement the delete method. As we can see, deleting is quite simple. We just remove it from our map and return an OK status without any content. So let's call get for our test counter again. It still returns our state. We now switch over to our delete statement for this. We get an empty result, which is basically the OK message. And if we call get again, we'll get an error that this counter is now unknown. So our example program is working as expected, and as you can see, it is quite easy to build a RESTful service. Alright, I hope you have enjoyed this quick screencast. If you want to use SIRIUS or want to learn more about it, feel free to watch the other screencasts or check out the source code on GitHub. Thanks for watching. If you liked this screencast, please give it a thumbs up and catch you next time.